What is apparent power? Apparent power P apparent is nothing but we have defined it as V into I. Okay. Now from this, what is cos theta? Cos theta is equal to P by P apparent. Okay. So I am naming it as P and I am naming it as Q. Sorry. Yes. So that cos theta is equal to P by S. Cos theta is equal to P by S. Now, now, if I give this power to an resistance, a power to a resistance, suppose if I send some current and if I have some voltage, okay, if I have an voltage, AC voltage, what will happen? The entire current which is going into this resistance will be dissipated as heat. Will be dissipated as heat. Okay, if I give this current and voltage to an inductor, what will happen? The same voltage and same current is given to a pure inductor. What will happen? What will happen? Suppose this is V and this is I. The amount of power that we are giving, that is the product of V and I, is stored in the form of energy, which is of Li square, where L is the inductance of this coil. Okay, that means when some reactive power, some power is given, what is happening to this power? It is going into this inductance and it is being stored. It is being stored. It is not dissipated as in case of resistance. Similarly with the capacitor also. If I give the voltage and if I pass the current through this, okay, then energy is stored in the capacitor and the amount of energy stored is given as half CV square if I is going into the capacitor. Okay, that means for a pure inductor and pure capacitor, energy is being stored. What are the power you are giving, that is being stored. Okay, that point is clear now. Now I want to calculate the power that is stored in the, that is given to the inductor, pure inductor. So if I say V into I is the power formula, okay. Now what is V? V is equal to L into di by dt. L into di by dt is the voltage formula into I. I is the current. Is it clear up to now? Okay. So what we are
diagrams ఒక్కసారి explain చేయరా?
Yeah. See here, anyhow we are going to deal these three topics in the next section. Whenever we give some voltage to a resistance, what will happen? Some current will flow into this resistance and the product of voltage and current is the power. Okay. What is the power given to this resistance? PR is equal to V into I. So that PR which is given to this resistance is dissipated as heat. Okay. So resistance won't have the property of storing the energy. Okay. It will dissipate whatever the energy you give, it will dissipate. If for a pure inductor, if you give the power, that is voltage and current, this current will go into this inductor and it won't dissipate it as a heat, but it will dissipate, it will store the energy. The energy that you are giving PL is stored in the inductance in the form of magnetic field. In the form of magnetic field. Okay. In the form of magnetic field.
Yes, sir.
Okay. Now, if I give some energy to this capacitor, suppose V is the voltage and I is the current, and PC is the power that is given to this capacitor, it will store it in the form of electric field. Okay. It will store in the form of electric field. Now I am trying to derive, I am taking this case 2, pure inductor case, and trying to derive what is the amount of power that is being stored in this inductor. Okay. Now PL is equal to V into I. Okay. Now L into di by dt is the voltage across the inductor and I is the current that is flowing in the inductor. Now let us consider I is equal to, Im, capital Im sin omega t. What I am considering? I am considering let I is equal to, Im sin omega t is the current that is flowing in the, inductor. Now what is PL? PL now becomes, PL is equal to, substitute I in this equation number 1. Suppose this is equation number 1. Substitute this Im sin omega t. So L into d by dt of, Im sin omega t. Okay, sin omega t into what is I? I is Im sin omega t. Im sin omega t. What is derivative of Im sin omega t? So Im is constant, L is constant. I am bringing these two, Im, L. What is derivative of Im sin omega t? Yeah, please tell me. Im is constant, so bring it out. So derivative of sin omega t is cos omega t. Okay, cos omega t into omega. Okay, so now my equation becomes omega Im square L. Okay, sin omega t cos omega t. Sin omega t cos omega t. Okay, cos omega t. What is sin omega t cos omega t? It is 1 by 2 cos 2 omega t. So omega L Im square 2, sorry, 1 by 2 sin 2 omega t. Sin 2 omega t. This is the final value of power that is being consumed by the inductance. The equation for the power consumed by the inductance. Now, what I'm going to do is, can anyone tell me what is PL? PL is equal to omega L into Im square into 1 by 2 sine 2 omega t. Okay. Now I can write Im square as omega L into Im by root 2. Okay. Into Im by root 2. Okay. Im by root 2 sine 2 omega t. Sine 2 omega t. Okay. What is Im by root 2? IRMS. Okay. Im by root 2 is IRMS and 2 IRMS. Okay. Into sine 2 omega t is your power T consumed in the inductance. Now we know that Z is equal to, what is Z value? Z is equal to R plus J XL. R plus J XL. That means, suppose this is your Z. Okay, this is your XL and this is your R. Okay, this is your R. Okay, so XL I can write it as omega L. XL I can write it as omega L. Then what is cos theta? Suppose this is your theta, then we can write cos theta as
R by Z.
Omega L by R. Z.
Omega L by Z.
Z.
Omega L by Z. Okay. Omega L by Z. Omega L by Z. Okay. Okay. Omega L by Z. Now, V is equal to I into R. Okay. In case of Z, what you are going to write? V is equal to I into Z. So VRMS is equal to IRMS into Z. Okay. VRMS is equal to IRMS into Z. In this, we are considering R as 0. Okay. R as 0. Then if we consider R as 0, then Z becomes omega L because R is equal to 0. Z is equal to J omega L. Okay. Z is equal to J omega L. Okay. So you remember this IRMS into omega L is equal to VRMS. VRMS is equal to that. So omega L into IRMS, what it is? VRMS, okay, into IRMS into sine 2 omega t. 2 omega t. Okay. VRMS into IRMS into sine 2 omega t. Okay. So from this, what is sine theta? From this triangle, what is sine theta?
Cos theta R by Z, sir.
Cos theta is R by Z. Okay. What is sine theta?
Omega L by Z.
L by Z.
Omega L by Z.
Z.
So omega L is equal to Z
Z
sine
into
theta.
sin.
Z into sine theta. So instead of writing this, okay, omega L is Z sine theta right here. Okay, into IRMS into sine 2 omega t. Okay, so what is Z into IRMS? Z into IRMS is VRMS. Okay, so VRMS, okay, into IRMS into sine theta, okay, into sine 2 omega t, okay, sine 2 omega t. Now, if I take the average value of this, okay, average value of this inductance, sorry, power consumed in an inductance, it becomes 0 because sine term is there, right? Sine term is there. So, so what I'm going to take is, I'm taking the maximum value of this is equal to VRMS into IRMS into sine theta. Okay, VRMS into IRMS into sine theta. So this is the power that is consumed in this inductive circuit, and I am naming it as Q. I am naming it as Q. Okay. So ఇక్కడ వరకు అర్థమైందా? So Q is equal to VRMS into IRMS into Q. Okay. Sorry. Into sine theta.
Into sin.
Okay. And P is VRMS into IRMS into cos theta. What is S? S is VRMS into IRMS. Okay. Now I can write. Can I write S square is equal to P square plus Q square? If I write like this, then what will happen? What is P square? V I cos theta. Instead of writing RMS always, I am writing VI directly, whole square plus. What is Q? Q square. VI sin
Sin theta whole square.
whole square is equal to S square. Okay. So VI whole square is equal to VI whole square into cos square theta plus VI whole square into sin square theta. So if I take VI whole square common, what will happen?
One.
Cos square theta plus sin square
square
theta.
theta.
What is cos square theta plus sin square theta? Is 1.
One.
1 sir, 1.
So VI is equal to VA. That means LHS is equal to RHS. LHS is equal to RHS. Hence, I can write S square is equal to P square plus Q square. Okay. Suppose this will be true when S, P, Q are the sides of a right angle triangle. That's all. అంతే కదా? If S, P, Q are the sides of a right angle triangle, then I can write S square is equal to P square plus Q square. If it is like this, can I write S square is equal to P square plus Q square? Triangle ఎలా ఉందనుకోండి. No, I can't
sir.
write. So I can write, okay, S square is equal to P square plus Q square only when S, P, Q are the sides of a right angle triangle. So suppose if you take this as theta, then what is cos theta?
P by S.
P by S. Very good. What is sin theta?
Q by S.
Q
By
by
S.
Q by S. Okay. What is tan theta?
Q by
Q by P.
Q by P.
P.
Q by P. Okay. Tan theta is Q by P. What is Q?
Opposite side.
The power consumed in the inductive reactance, right? So let I square omega L is the power consumed in the inductance, and P is the power consumed in the inductance. Okay, so I square get cancelled. I square get cancelled. So tan theta is equal to omega L by R. Theta is equal to tan inverse omega L by.
Omega L by.
So what is this tan theta? So if you take cos of that theta, you will get some value, which is nothing but your power factor. That means this theta, the cos of this theta is nothing but your power factor. What is power factor? In the last class we have defined. Power factor is the cosine of angle between. What is the power factor? Suppose this is your voltage, okay, waveform, and if this is your current waveform, okay, and the angle between these two is, suppose say phase angle is theta, then cos theta is nothing but your power factor, which we have defined in the last class. Okay, Cos theta is nothing but your power factor. That means the power factor will exist only when there is a phase difference between voltage and current. What is this voltage and current? Suppose this is an inductive circuit. Suppose this is an inductive circuit and you are giving some voltage and current, right? We are giving some voltage and current to this inductive circuit. Okay, so this voltage and current lags, or there is a phase angle between voltage and current. That phase angle we are calling it as power factor. The more the phase angle, the more the power factor. Okay, so if if theta is equal to 0, theta is equal to 0 degrees, then P is equal to how much? Vi cos 0. Cos 0 means 1. That is equal to Vi. Okay, that means the entire real power or true power is utilized as, so Vi is S. So this is apparent power. True power becomes equal to apparent power. If theta is equal to 90 degrees. So before that, let me tell you what happens to Q. Then Q is equal to how much? Vi sine 0. So what will happen? 0.
Zero.
That means the reactive power consumed is 0. Okay, the reactive power consumed is 0. That means if I make the voltage and current phase angle 0, the angle between voltage and current 0, then reactive power consumption is 0. That means there is no inductance effect. That means it will have only pure resistance. Okay, theta is equal to 0 is the condition when it is a pure resistance. Pure resistance. When it is a pure resistance, then only we will have the phase angle 0 degrees. Then reactive power consumption is 0. Reactive power consumption 0 means there is no inductance or no capacitance. If there is no inductance or no capacitance, then what should be there? There should be resistance only. So in a pure resistive network, what will happen? Theta is equal to 0 degrees. The phase angle between voltage and current is 0 degrees. Now, in the second case, if theta is equal to 90 degrees, can you tell me what will happen?
P is equal to 0.
If theta is equal to 90 degrees, reverse will happen. P is equal to becomes 0. P becomes 0 and Q becomes S.
1.
Becomes
Vi.
S. And cos theta becomes
0, sir.
cos 90.
0.
0, sir.
Here cos 0 is 1. Okay. Cos 0 is 1. When the power factor is 1 means we call it as unity. 1 we call it as unity. When power factor is unity, it is a pure resistive. When power factor is 0, what we are calling? It is a pure inductive or capacitive circuit. Okay. Resistance aithe ledu because P is 0. So definitely there will be an inductance or capacitance. Resistance is not there. So there will be a capacitance or inductance. When there will be capacitance? When theta is leading
90 degrees.
90 degrees, then capacitive. When theta is lagging 90 degrees, okay, when theta is lagging 90 degrees, then inductance, pure inductance. When theta is leading, pure capacitance. When theta is lagging, pure inductance. What is meant by lagging or leading? I will tell you. Suppose if you take a voltage as reference and if current is leading the voltage by a 90 degrees, when current is leading the voltage by 90 degrees, then it is a pure capacitive circuit. It is a pure capacitive circuit. If you take voltage as reference and current is lagging behind the voltage, this is voltage and this is current, and current is lagging behind 90 degrees, then it is called pure inductive circuit. Then it is called pure inductive circuit. Okay. Based on the lagging or leading nature, we are deciding whether it is a pure inductive or pure capacitive circuit. Okay. So let us conclude this one. Suppose there is a pure inductance, cos theta will be how much? Cos theta will be how much? 90
Zero.
degrees, 90
90
degrees
value is
lagging, 90 degrees lagging. Okay, that means if cos theta ఎంత అవుతుంది? Zero, right? That
zero.
means we call it as zero power factor lagging. We call it as zero power factor. Very, very important. Zero power factor lagging. Okay. Here lagging means with respect to voltage, the current is lagging. Okay, if I make reverse, everything will get reverse. So in a pure capacitive circuit, cos theta is again 90
90
degrees,
degrees
but it is
leading.
leading. 90 degrees leading, and it is also zero. It is also zero. So here what we have to say? Zero power factor, leading. Okay, zero power factor leading. That means whether it is capacitive or inductive, we are getting zero power factor as common. Zero power factor is common, but lagging or leading decides whether it is a inductance or pure inductive circuit or pure capacitive circuit. If it is a pure resistive circuit, cos theta is 0 degrees, right? There won't be leading or lagging. So cos 0 is 90 degrees. So here I will write theta is equal to 90 degrees. Here theta is equal to 90 degrees. Here theta is equal to 0 degrees. Okay. So power factor is unity. When power factor is unity, what we call? We call it as a pure resistive circuit. And in these three cases, first case, second case, and third case, what is going to happen? In a pure inductive circuit, the current lags the voltage by an angle 90 degrees. Okay. In a pure capacitive circuit, the current leads the voltage. This is voltage and this is current. Current leads the voltage by an angle 90 degrees. This is your voltage and this is your current. And in the third case, when it is a pure resistance, the voltage and the current will be in phase. That means here theta is equal to 0 degrees. Here theta is equal to 0 degrees, and here theta is equal to 90 degrees, and here theta is also 90 degrees. But what you have to tell, it is lagging, and here leading. Okay, and here unity, or I can say in phase. Okay, in phase. Okay. So here 1, 2, 3, three cases we are going to learn. One is the inductance, second one is the capacitance, and third one is resistance. So When will be the inductance? When will be the capacitive circuit will be dominating, and when will be the resistive circuit will be dominating? It depends upon the amount of resistance or capacitance or inductance. So don't think that always the circuit will be pure inductance. The circuit can be a combination of RC. The circuit can be a combination of RL, and the circuit may be a combination of R, L, and C. Okay, so there is a chances that the combination of RL, RC, and RLC circuits. Okay, RL, RLC circuits. Then what you are going to tell now? Then what you are going to tell now? In this case, cos theta is equal to cos theta, and theta will be lying between 0 and 90 degrees. Okay, but not 0 and 90. It will be between 0 degrees and 90 degrees. Okay, lagging. Okay, any angle between 0 and 90 degrees based on the value of R and L. So theta is equal to, here in this case, tan inverse omega L by R. Based on the R and values, we are going to get, I'm going to get whether uh, lagging. Okay, and here also, sorry, capacitive means leading.
Leading.
Okay, here also cos theta will be there, but this also will be 0 less than, okay, theta less than 90 degrees. Okay, okay, it will be between 0 and 90 degrees, but not equal to 0 or not equal to 90 degrees. Theta is equal to tan inverse omega L by R. It is omega L by R. This is 1 by R omega C. Okay, this is R omega C. Here, theta may become negative. Theta may become, here theta is positive. Okay, and in this case, cos theta can be 0 less than or equal to theta less than or equal to 180 degrees. Okay, you can get anywhere. So if I want to write the angle for RC, so RC will be here. So the theta will be varying from here to here. Okay, RC. For RL, it is this one. Okay, the theta will be this one. Okay, in this region, this is RL. Okay, this is RC and this is RL. And RLC, both areas. Both areas. Theta may be lying between both areas. That means if this is your voltage vector, okay, okay. So the current vector will be sorry, not in this region. This is RL. RL will be in this region. Okay. So the angle, so this is RC region. Okay. So the locus of this point will be like this. Okay. And this will be RL. RL region. So the angle between these two is based on the value of R and L, and the magnitude of this angle depends on R and C value. Okay, am I clear up to now?
Yes, sir.
So can I ask you a few questions? So if I'm going to draw one vector for you. This is the voltage. This is the voltage. Okay. And this is the current, and angle between them is 36 degrees. Okay, 36 degrees. This is current. So what type of circuit is it? It is RC circuit. RC. Okay, it is RC circuit, and the circuit will be like this, RC. Okay, RC. Okay, this is R, this is XC. Then what is theta? Theta is equal to 36 degrees. Theta is equal to 36 degrees. Now, can you tell me what could be this circuit? What could be this circuit? This is V, this is I. What could be the circuit?
RL.
No, this is pure
Pure
inductive
inductive circuit, sir.
Pure inductive circuit. Okay, pure inductive circuit. So this is the circuit. Because theta is equal to 90 degrees. Theta is equal to 90 degrees and lagging. Theta is 90 degrees and lagging. Okay, now this is voltage and this is current, and the angle between them is 57.8 degrees. So what could be the circuit? RL circuit. This is RL circuit. So this is R, this is L. So this is the circuit, and this is the voltage, and this is the current. This is the voltage and this is the current. This is the voltage and this is the current. Okay, because theta is 57.8 lagging. 57.8 lagging. Okay. So I will give you some more examples. Suppose this is V and this is I, and both of them are having an angle difference of 90 degrees. Then what is the circuit?
Pure capacitive circuit.
Pure
Yeah,
capacitive,
pure capacitive circuit. Pure capacitive circuit is a pure capacitive circuit because theta is equal to 90 degrees and leading. 90 degrees and leading. Okay. Now you tell me an angle between them is 90 degrees. What is this?
Pure resistor.
Hmm?
RC, sir.
It is a pure inductive circuit. It is a pure inductive circuit because theta is equal to 90 degrees lagging. ఎలాగో చెప్తారా? You rotate this vector 90 degrees, then what will happen? V will come here. Okay, and I will come here, right? Now, how is I? I is lagging behind voltage by an angle 90 degrees. So it is a pure inductive circuit. Okay. నేను ఇక్కడ voltage current మార్చాను చూడండి. So what you have to do? You have to rotate this voltage because you know you have written all the examples using V and V as on x-axis. Here V is on x-axis and here V is on x-axis and here V is on x-axis. So మీకు V is on x-axis తో అలవాటు కాబట్టి you rotate this V so that you can observe. Okay. So I will give one more example for you. Tell me. What is this circuit?
RL circuit.
R
RCC.